Okay, we're going to start with our next lesson. It's something we've already looked at a little bit, but we're going to go to it in a little bit more detail. So we're going to look at proving trig identities, and this title page that I've used a couple times now is showing you a proof. So what we're trying to do is, this is an identity that's on your formula sheet. What we're trying to do is show that they're both the same thing. So what we do is we take the left-hand side and try to rearrange it so that it's equal to the right-hand side, or vice versa. So sometimes you change one, sometimes you change the other, sometimes you change both, and so on. So in this case, if we take cos 2x and break it apart so that it's x plus x, then we can use the identity where we have cos of two angles. In this case, they're both the same, so it would be cos minus sine, which is the same thing as cos squared minus sine squared, which is the right-hand side. So when you're dealing with trig identities, what you want to do is we need to try to prove that both sides of the equal sign are exactly the same. And to do that, you either change one or both the sides until you get them to be exactly the same. We're not solving the equation, so like with a normal equation, you're trying to solve it, so you're rearranging and dividing both sides by something and so on. We're not flipping things from one side to the other. All we're doing is working on each side by itself, one at a time, to try to get them to be the same thing. So steps that you want to go through to work on these is, typically the best bet is start with the more complicated side. So whichever side looks harder, so usually start there and try to make it easier. It's a lot easier to do that than it is to take something easy and try to make it more complicated. Once you do that, you're going to use your identity sheets, pick one of the identities, and make substitutions. So quite often with an identity you can substitute to something else, and that'll help change it. And then another strategy quite often is get rid of any cotans or tans or secants, use just sines and cosines. And then our last step is use other math skills like factoring, common denominators, etc. to try to simplify it further. So let's go through some examples and we'll see how this stuff works. So our first example here is, we want to prove that 1 minus cos squared equals sine times cos times tan. So sometimes what we do is we kind of break it into two sides. So you can draw a line down the middle if you want, or whatever. But so the idea now is we want to make these things equal to each other. So if we take our 1 minus cos squared, and let's simplify that. So it's, if we use our identity sheet, there's an identity that's sine squared plus cos squared equals 1. So you can see if we go 1 minus cos squared, if we bring that cos squared to the other side, that'll equal sine squared. So that side will equal sine squared. And let's just leave it there. Take our other side. Let's leave the sine alone. Let's leave the cos alone. And let's change tan into sine over cos. So we can see that our coses would cancel. And all we would get left over is sine times sine, or sine squared. Now we got these two things equal to each other. We're done. So we proved that they're the same just by using a couple identities to rearrange things. Okay, here's another one a little bit harder. So we have 1 plus cos 2 equals sine 2 equal to cotan. The left side definitely is harder, but let's even start with the right side. So cotan would be cos over sine, so we'll just leave it at that. And now let's work on the left-hand side. So for the left-hand side, we want to change the top and the bottom. So let's start with that. The bottom one, let's start with that one. That one's a little bit easier. If you look on your identity sheet, sine 2x is 2 times sine x cos x. So that one's pretty easy. The top one's a little bit harder. So what you want to do is make sure you pick the right identity. So we have 1 plus cos 2x. So if we go through our identities, we see that we get one that has cos 2 equals 2 cos squared minus 1. So that's the one we want to pick. If we bring the 1 to the other side, let me just kind of jot it down here. So cos 2 angle equals 2 cos squared minus 1. So you can see if we bring the 1 over, we have 1 plus 2 cos. So we can see that that's just going to be equal to 2 cos squared x. And if we simplify a little bit further now, we can see we got a 2 that we can cancel. We got a cos on the bottom with 2 on the top, so we can cancel one of those. So that means that left-hand side would end up being cos over sine. Now both sides are the same. We're done. We've proved that it's equal to each other. Okay, so a lot of these you're just sort of rearranging each side of the equation to try to get it a little bit simpler or a little bit more like the other side. Okay, here's another one. We got cos over 1 minus sine plus cos over 1 plus sine. And with this one, you can see there's really nothing to change. We got no identities to work with. So a lot of times with these kind of questions, you're going to have to do some factoring, you're going to have to do some common denominators, anything like that. This one, we're going to common denominator because of that plus sign. So remember with fractions, like if I gave you 1/3 minus a quarter, or plus a quarter, doesn't really matter what it is, we would have to times each fraction by something to get a common denominator. So we times this one by 4 to get 4/12, times this one by 3, that would give us 3/12, and once they're the same denominator, we'd add them together to get 7/12. So that same logic has to apply. We've got a common denominator, in this case of 1 minus sine x and 1 plus sine x. So we're going to have to times each fraction by whatever is missing. So this one we're going to have to times it by the 1 plus sign, top and bottom. So if we do that on the top, that would give us, now let's FOIL it out. So we'd have cos x times 1 and cos x times sine x. And if we do the same thing with the other one, we times it by 1 minus sine, top and bottom. So the top, if we FOIL that one out, we would get cos x minus sine times cos. Oops, I forgot the cos on this one when we FOILed it. And that's it. So you can see we've got our tops done. So now let's simplify. We've got a plus sign and a minus sine cos, so those will cancel. We've got cos plus cos on top, so that'd be 2. And on the bottom we have 1 minus sine and 1 plus sine. We can actually FOIL that out. So 1 times 1 would be 1. And we got minus sine times plus sine would be sine squared. The middle terms would cancel. We'd have a minus sine x and a plus sine x, which would cancel. We can write them in if we want. I'll do it now, but we won't bother doing it usually. And that's it for that side, so you can see those ones cancel. So our last thing is we know that sine squared plus cos squared equals 1. So 1 minus sine squared then would equal cos squared. So we can change our bottom then to be 2 cos x over cos squared. And we can cancel one of the coses with one of the ones on the bottom, so that simplifies to just 2 over cos, which is exactly what our right-hand side was to start with. When you're dealing with proofs, you can quite often have different strategies, but still prove that it's the same. So in this case, I chose common denominators and worked it out that way, and that worked fine. But there may be other strategies that, depending on the question, may work better or just different. And let's do one more. Here we got cos to the 4th minus sine to the 4th. There is no identity on your sheet that has fourths, but if you think back to, like if I gave you a question like x to the 4th minus y to the 4th, we could factor that into x squared minus y squared times x squared plus y squared. And if we can do that in this case, or once we have squareds, that is our identities. So we'll use basically the same logic. If we factor the left-hand side, you would have cos squared x minus sine squared x as one factor, and the other one would be cos squared x plus sine squared x. And we can keep going now. So using your identity sheet, we know cos squared plus sine squared equals 1. And if we look further down on the list, there's a cos squared minus sine squared, which is equal to cos 2. And that's it. You can see we're pretty much done. So we have cos 2x times 1, or just cos 2x. And our other side of the equals sign was cos 2x. So once we factored it and then used our identities, it was pretty easy after that. And that's it for today.